This unit we're going to talk about alkenes and isomerism in alkene or of alkenes. So what are alkenes? Alkenes are a group of hydrocarbons. Remember we said we have three groups of hydrocarbons: alkanes, alkenes, and alkynes. So alkenes are a group of hydrocarbons which conform to a general formula of CnH2n, where we said N is a number starting from 1 to as you proceed like that. And alkenes have a double bond between their carbon atoms. Another thing about alkenes, we say they are unsaturated. Okay, we say that they are unsaturated, meaning the carbon atoms are not bonded to the maximum number of atoms that they need to be bonded to. Now, what does this mean about alkenes? So this means these unsaturated alkenes, when you combust them, you're going to have the production of a yellow sooty flame, and that is also a test for alkenes, okay, or for unsaturated hydrocarbons. Now let us go to isomerism of these alkenes, or maybe we can say the first member of our homologous series in alkene is ethane. Okay, so we start with ethene. The first member in our homologous series in alkene is ethene. So how do we write ethene? Ethene is written as, so we say the first member is ethene with a formula of C2, with a general formula of C2H4. Okay, so we start from ethene, and then we go to propene, and then we go to what? Butene. Now, how do you know the names of these alkenes? So we get the name of the alkenes by replacing the suffix of our alkanes. So remember, alkanes had a suffix of A-N-E. So alkanes, these are alkanes. Alkanes had a suffix of A-N-E. Okay, so you get the alkenes by replacing the suffix an with en. That is how you name the alkenes. Okay, so we have ethene, propene, butene, hexene, heptene, octene, nonene. All those alkanes, if you replace the suffix with en, you form your alkene. So we have said this is the general formula. So we have said that they conform to a general formula of CnH2n, meaning if this is your ethene, your propene is going to be what? Your propene is going to be C3 with 3 carbon atoms still, okay? And then we are going to have our H is going to be what? 2, you multiply by N, which is 3, the number. So you're going to have 2 times 3 giving you what? 6. So your propane is going to be C3H6. Butene, on the other hand, is going to be C4, your H2 into bracket N, and our N, the number is 4, meaning 2 times 4 is 8. So our butene is going to be C4H what? H8. Now, when you go to the isomerism, what do we have? We say alkenes exhibit 2 types of isomerism: positional isomerism and branch chain isomerism. Positional isomerism is affected by the position of your double bond. So for you to have an isomer here, positional isomer, you just shift the location or the position of your double bond in the longest carbon chain. Okay, now let us do an example. So we are going to talk about still butene. So let us talk about butene. Butene, meaning we have how many carbon atoms do we have in butene? We have 4. So let us write our 4 carbon atoms. 1. Remember we said we have what? Double bonds. So we are going to have 1, 1, 2, 3, 4. Then you're going to put your hydrogen. Here you have one hydrogen, there we have another, like that. Here we have the carbon is bonded to 3 other atoms, so we are going to have like that hydrogen, and also here we are going to have 2 hydrogen atoms only. Now this is butene. Okay, now let us look at the position of the carbon double bond. So the position is in our first carbon atom. So this is the first carbon atom, the second, the third, and the fourth. Remember, while naming, we said you name while starting from the side that is going to give you, a double bond, the least number. Okay, so in this case, it's this side. This is 1, 2. So our element are going to name it as butene or but 1 in. Okay, because the position of the double bond is in the first carbon atom. Now let us look for the other positional isomer of butene. Where else can we change the carbon atom to? We can put it here. Okay, so we can come and write, we have the 4 carbon atoms. Okay, and now let us change the position of our double bond from the first carbon atom to the second carbon atom. So we can have the double bond where? The double bond there. And then this represents the number of hydrogen. This represents our hydrogen atoms. You can see we have changed the position from the first carbon atom to the second carbon atom. So when you're naming, we've said we name from the side that is going to give our double bond the least number. So let us start from this side. Here we have 1, 2, 3, 4. From this side it's 1, 2, 3, 4. Okay, so we can label from this side because that is where we are going to get our double bond having the least number of having the least number. So we are going to label from this side. So this is going to be but 2 in, because the position of the double bond is in the second carbon atom. Now can we have another positional isomer of butene? No, we cannot. Yeah, because if we put it here, we are going to have the double bond in the first carbon atom. If you put it here, it's still the first carbon atom. So that is positional isomerism, where you just have to shift the position of your double bond for you to get an isomer. Now when you go to branch chain isomerism, this is where it occurs due to the presence of a branch in our continuous chain. Now we are going to talk about an example, which is hexene. So hexene is an alkene with 6 carbon atoms. So we are going to write it as C6. How many hydrogen atoms are we going to have if we use this formula? So it's going to be 6 times 2, which is what? Which is going to give us 12. Okay, so let us draw the formula of our hexene. So we're going to have 6 carbon atoms. 1, 2, 3, 4, 5, 6. So first write and then pick the position of your, and then you're going to pick the position of your branched alkene. Okay, so what we're going to do in this case is we have the 6 carbon atoms and we're looking for, so this is the formula. So we know this represents our hydrogen atom. So here we have hydrogen, 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 like that. Now we have a double bond there. We cannot put it there. That is our. Now this is our hexene. So let us look for the branched isomer of hexene. So you can say it's hexene or hex1 in, because of the position of the double bond. So the isomer is going to be, we're going to take our functional group and we are going to detach and reattach it somewhere along our carbon atom. Okay, so let us take this one. So we're going to take that methyl group. So we're going to draw 1, 2, 3, 4, 5 carbon atoms. 1, 2, 3, 4, 5 carbon atoms. We're going to take our methyl group, and so our double bond is there, and we're going to place our methyl group somewhere along there. So we are going to place it. We are going to place it. Now, in our branch chain isomerism, we're going to say we are going to shift our constituent methyl group to a certain position within our hapa. Okay. So when it comes to branch chain isomerism, we are saying it is going to occur due to the presence of a branch in the continuous chain. So we have a continuous chain here of an alkene, which is hexene. Okay, so as you can see, this is our hexene. If you look at the position of your double bond, you can see it is in the second carbon atom, meaning the name of our element here is hex 2 in. Okay, of our compound is hex 2 in because of the presence of the position of the double bond in the second carbon atom, giving us this number 2 here. So let us look at the isomers of hexene. This occurs due to the presence of a branch in our continuous chain. So we have a branch in a continuous chain. So we're going to look at hexene. So the isomers of hexene, this is the structure of hexene. Okay, so here we have hexene with the double bond occurring in the second carbon atom. That's the name hex 2 in. 2 is because of the position of the carbon double bond. Okay, now the isomers of hexene include this. So the first one is 2,3-dimethyl but 2 in. Now how did we name this one? So as you can see, first we identify the longest carbon chain, and we have 1, 2, 3, 4. This is the longest carbon chain. Okay, so the number of carbon atoms present here are 1, 2, 3, 4, 5, 6. So you can see the formula is C6. How many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So H12. Okay, so that is the formula of this is the formula of an isomer of what? Of hexene. So we are saying it is 2,3-dimethyl but 2 in because of the position of the methyl group. So we have the methyl group being positioned in our second carbon atom. Okay, so we said we are going to label it first. We identify the longest carbon chain. The second thing that we're going to do is we're going to name it from the side that is going to give our double bond the least number, and also the methyl group the least number. So we are going to have 1, 2. This is the first methyl group, which is in the second carbon atom. 3, here this is 1, 2, 3, 4. Okay, so the first methyl group is in the second carbon atom, and then we have another methyl group in the third carbon atom. Okay, so as we name, what are we going to do? We are going to identify the longest carbon chain, which is butane, because we have 1, 2, 3, 4 carbon atoms. And then the other thing that we are going to do is we are going to identify or to name from the side that is going to give us the double bond, the least number of the position, which is going to be having the least number of atoms. And then now, when it comes to branch chain isomerism, we are going to look at a branch forming from a continuous chain. Okay, so in this case, we have hexene or hex 2-ene. It's hex 2-ene because the position of the double bond is in the second carbon atom. So when you're looking at the isomer of hex 2-ene, we're going to look at where we're going to put our substituent or our functional group, which is our methyl group in this case. So we're going to take our methyl group, which is this group, okay, and then we're going to put it in any carbon atom to create a branch. It is branch chain isomerism. So if we take this methyl group and put it in the second carbon atom, and also take another methyl group and put it in another carbon atom, we're going to form a 2,3-dimethyl but-2-ene. So how did we identify it? First, we identified the longest carbon chain. After we identified the longest carbon chain, we followed all the rules. So how did we identify it? We followed the rules of naming our alkenes. So the methyl group, the first methyl group is in the second carbon atom, and the other methyl group is in the third carbon atom. So it's going to be 2,3-dimethyl but-2-ene. Now, the other isomer is 3-methyl pent-2-ene, where we had one methyl group in our third carbon atom. So it is, we are going to label from this side. We have 1, 2, 3, 4, 5. Following the rules of naming that we've talked about, you can check it in our other video. We are going to have this isomer being labeled as 3-methyl, the position of our methyl group. Okay, so 3-methyl pent-2-ene.